Hello, we're looking in lesson 9-4 in your geometry part 2 textbook. This is found on page 572. Problem number 2 is talking about a reflection across two intersecting lines. Now, there's a theorem for that. If you look right above problem 2 on that page, it tells you that when you reflect across two lines that intersect, if you reflect and then you reflect again, excuse me, we're going from here to here. If you reflect, which it would look like this, and then you reflect it again, it would look like this. What you're going to find is that's the same as rotating it around the place where the two lines cross. It just ends up being that way. And what you're also going to find out, which is what they're going to ask you about down in this problem, is what kind of rotation? Well, it's always going to be twice the distance of this angle right here that was made between the two intersecting lines. That rotation will be twice the distance or twice the rotation of that angle right there in the middle. So if we're going to take J in problem number 2 here, and we're going to reflect it over the L axis first, and then of course over the reflected over the M axis, which is what that's really saying to do. It's called a composition of function. But you're going to take that first. You're going to reflect J across the L axis, and then you're going to reflect it again across the M axis. It's trying to show you that if I reflected J, which is here, the same as it is here, it's just redone. If I reflect it, it's going to look like this one in the light gray. If it gets reflected again, it's going to look like this one down here, which is in the blue. Now, what they're trying to prove to you here is that as you work through this, that it's the same, again, if it got reflected and then reflected again, that's the same as getting rotated through. Now, what you're going to find out and what they're trying to say here is they're trying to prove to you mathematically that if this angle right here was 70 degrees, then they split it into 4 segments. So that would be 70 right there, and that would be half of 70 and half of 70 for a total of 140. And so what you're going to find out to be true always is that the total rotation is going to be double whatever the angle was where the two lines meet, and the reflection point is going to be where the two lines, or the point of, not reflection, but the point of rotation is going to be where the two lines cross. Okay? So, in the Got It section, use the diagram at the right. What is the reflection of J over A, and then again over B? So if we reflected it here, and then we reflected it back over here, it's saying what is the center and the angle of rotation for the resulting rotation. C is going to be the center of rotation because it's where the two lines crossed each other. And so a double reflection, again, is just going to be a rotation of, if that's 45, then the total rotation is going to be a total of double that, or 90 degrees. Okay? And so anyway, that's just the way it always works out, and you'll find that to be the case not only in this problem, because of the theorem at the very top of the page, it's true for all of them. So I hope this turns out to be helpful for you.